This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio. I'm your host, Jeff Doolittle. This episode will explore the role of human programmers in the AI era. Topics around machine learning and AI have come up frequently in previous episodes. Some examples are episode 633 with Itamar Friedman on automated testing with generative AI. Episode 603 hosted Rish Singh on using Gen AI for test code generation. And in episode 626, Ipez Oskaya joined Software Engineering Radio again to discuss Gen AI for software architecture. Today, we're hosting Artie Shevchenko, who is a former Google software engineer, ex-CEO, and founder of a startup. Currently, he's a software engineer at Canva and a lecturer at ITMO University, which is famous for winning more programming World Cups than any other university in the world. He is also the author of the recently published book, Code Health Guardian: The Old, New Role of Human Programmers in the AI Era. Artie, welcome to the show.
Thanks for having me.
Glad you're here. The subtitle of your book, as I said, is The Old, New Role of Human Programmers in the AI Era. In your view, what does it take for programmers to be successful in the era of AI?
I think there are three things you need to be great at. One is collaborating with AI. Another is delegating to AI. These two are very much on the hype right now. Everybody talks about Copilot and Cursor, I guess. But there is also one more thing there. You really want to be better than AI at something. And if we were talking about software engineers, I would say your best bet is to become an expert in managing code complexity. Just because complex reasoning is hard for AI, and in software engineering, that's probably the hardest problem we have. How do we keep our code bases reasonably simple? So yeah, honestly, I wouldn't over-focus on learning these AI tools like Cursor and Copilot today, and really spend some time to make sure that you're ready for this new role of human software engineers, which is Code Health Guardian. That's how I call it. And that's the title of the book.
So you mentioned the idea of complexity. In case it's unclear to our listeners, help us connect. How does complexity relate to this idea that you describe about programmers as code health guardians?
Yeah, definitely. When I say code health, I basically mean code that is simple enough, code that is reasonably simple or maintainable. So if that's the hardest problem in software engineering, to keep our code bases simple enough, then it's likely that we will continue to be better than AI in this for at least some time, maybe years, maybe even decades. So yeah, that's basically the link there.
Why does AI struggle to keep things simple in your experience?
Complex reasoning is hard for AI, so it looks simple on the surface often. I think that's what AI is very good at. It gives you an impression that it understands things, right? And it gives you an impression that, okay, that's super simple. It's like 1, 2, 3, here you go. But sometimes the real world has very significant challenges that need to be deeply understood. And that's what humans still do better than AI at this point.
So would you say sometimes the AI comes up with simplistic solutions rather than simple ones? Okay. So your contention is that humans still need to maintain this sense of complexity management, and the way we do it is by guarding the health of our code?
Yeah, exactly.
And you mentioned maintainability. Are there other aspects to code health? You mentioned simplicity and maintainability. How else would you characterize code that is healthy?
That's basically the definition. If we're talking about definitions, I just use the term health as an alternative to saying that is reasonably simple or pragmatically simple. But I like to think about code health as a productivity question. I think it is ultimately a productivity question. So if you think about human productivity or programmers' productivity, the first thing that comes to mind is team productivity, right? There are a bunch of factors that make team either productive or not productive, like psychological safety, reliability, clear goals, clear responsibilities, impact, all this kind of things. But if we zoom in a little bit into an individual in a team, still in a reasonably productive team, you will have individuals which perform really great and individuals that perform not that great. And historically, if you're an engineering manager dealing with this issue, the question you're asking yourself is, well, is it a skill problem or is it a will problem, right? But I find that often the answer to this question is no. It may be all good with skills and it may be all good with the will. So for me, I don't think I ever had any major issues with the will problems or skill problems. For me, I definitely had some issues with finding the right balance between long-term and short-term productivity. And that's what I call term productivity. It's pretty hard to talk without any visuals, but if you can imagine having a spectrum where on the left side it is short-term productivity and on the right side it is long-term productivity. If you're too focused on the long-term productivity, it's kind of obvious why you're not productive, because you're often planning to be productive in the future, right?
Someday I'll be productive, right?
Yeah. And if you're focused too much on the short term, you become too tactical, you create too much complexity along the way. And that's what AI agents could do for us too. And you really want to have the balance there. You want to care about users' needs right now to deliver now, but also care about user needs like a year from now, so that you don't create too much complexity so that you cannot execute in a year from now.
Right. So a few interesting insights from that. One, you didn't seem to say that long-term or short-term is better. There's a balance between long and short-term productivity. Yep. Did I understand that correctly?
Yeah, that's correct. And definitely there are times when you need to focus on the short term for several weeks or maybe even months and just deliver. There are times when you need to focus more on long term. But in general, you need to find a healthy balance between these two extremes and be somewhere in the middle.
Okay. And then the other aspect I think you're implying as well is that it's humans' job to ensure long-term productivity, that AI might make us short-term productive, but that at least as it currently stands, it's not going to solve the problem for us of long-term productivity. Is that correct?
Yeah, exactly.
Okay, great. Well, that might lead really well into my next question, which is what motivated you to write Code Health Guardian?
Well, I guess I was always passionate about knowledge sharing. So even starting with my uni years, I remember we were doing classes for high school students and even primary school students a little bit. And right now I'm teaching in university, doing university classes. So yeah, this passion for knowledge sharing was pretty much always there. But in terms of this particular book, I guess there are three key events there, apart from doing the university classes, which definitely prepared me for writing this book because they inspired, the content of those classes inspired the content of the book very, very much. But there are two other key events I would mention. The first one is doing good code reviewer internal classes at Google. So the story there is that when I was at Google, I was pretty much every day, I was just spending a little bit of time reading random documentation. And at some point, I started realizing that there is so much information about how to do code reviews on our intranet. And I just wanted to consolidate all of that. So that's what I did. I just consolidated all of that, created a single slide deck for that. And at some point, that slide deck became pretty popular. And I even started getting requests from other Googlers asking whether there are any tech talks about this, if there are any classes about this. So I started doing the good code reviewer classes internally at Google, and that was pretty successful. I think in just 1 year, we had over 1,000 Googlers, software engineers, who went through those classes. We got like astonishing 4.5 rating based on over 100 reviews. And that's really a golden standard at Google for tech talks. Like, when we're doing onboarding, that's roughly the rating you get for those onboarding classes. And like if you can reach 4.5, that means you've done a good job.
Yeah.
So yeah, that was the first key event, doing those classes. It gave me quite a lot of confidence, I guess, to start university courses later. The second key event was John Osterhood book presentation in Google's Sunnyvale office. So I just randomly ended up being there. I had no idea what to expect. I guess it was just advertised via some internal channels. And I ended up being in that room, just knowing that some guy is going to present on his software engineering book. And when he was talking about software engineering and complexity causes and complexity symptoms, as he called them, that really resonated with me and was like, oh yeah, that really makes sense. And yeah, then when I was starting the university classes, I think to a large extent, maybe up to 50%, the initial content of those university courses was actually based on John's book, Philosophy of Software Design. Also, of course, my own experience at Google and a bunch of other books like Pragmatic Programmer, but John's book was very, very key.
That's great. And I'll put a link in the show notes to Software Engineering Radio episode 520, where I interviewed John Osterhout about his book, A Philosophy of Software Design. So that'll be good for listeners to be able to dig into. So a lot of our guests on the show have written books, and my understanding, having not published a book myself, is that it can be challenging. So what helped you to stick with it along the way?
Yeah, it was a long process. I started it in 2022. At that point, Software Engineering at Google book was already published. And a bunch of things that I've learned internally at Google, I was surprised that they were not covered, because I was expecting it to be a lot about actually coding and software design and all this stuff, how we do this internally at Google. But if you take a look at the Flamingo book, there is not much about it. There, it's mostly about building engineering organization.
Okay.
So that gave me a feeling that there's an opportunity there. Already at that point, I've been iterating on the university classes for quite a long time. So I've had quite a lot of insights into how to communicate complex topics in a simpler way, but also some unique insights about software design as well. And in 2022, when I suddenly got quite a lot of time, I decided to start writing the book. So I did a couple of chapters, and one of the chapters was on design docs. So I reached out to Max Kenneth Alexander, the author of Code Simplicity, with that draft, asking for his feedback. And I guess that's one of the turning points when you want to get support from somebody, because you're kind of like, you're just starting and you're not completely sure how will it go. And what Max did, he actually referred me to Titus Winters. He was saying, look, for this, you probably need to talk to Titus. He was curating software engineering at Google, and he can give you feedback for this. So that's what I did. I asked him for a warm intro. He did me a warm intro, and I sent it to Titus. And Titus was so supportive. He looked through the chapter draft and said that, well, look, it looks great. For different reasons, we decided to keep the design docs section in software engineering at Google pretty short. But yeah, it's definitely worth making it public and talking about this. To which I responded to him saying like, hey, do you want to write this together or write this book together? Maybe overly ambitious. But at that point, I already went through the YC, Y Combinator startup school, and was running a startup. So like I was a little bit pushy. But Titus said like, that would be great. That's a great project, but I don't really have time for this. Anyway, Titus' support was very important in the beginning. I guess that what made me brave enough to continue working on it. I guess the second turning point was when, after a year of writing, I realized that the scope is a little bit too big. Because originally the name of the book was Productive Software Engineering. That's what I wanted to, that's the name of the university.
Very broad.
It is, yeah, but that's the university course. And I was thinking maybe I would just publish my university course. And it has two parts. It has this technical part, which is about code complexity, and has like non-technical part. But after a year, I realized, that's too much. It would be Talmud if you can say it in English.
Right. That's the word.
Yeah, a very, very long book. So I've reduced the scope and decided to focus solely on code health and decided to let it be a story of a healthy code base. So that was the second part that really helped actually complete this work. And the third turning point, not a turning point, but I received a lot of support from tech reviewers. So that's something I didn't expect, but there was so many, like dozens of people who left a bunch of comments on the manuscript and helped to make this book much better. So yeah, I guess these three events or turning points.
Great. Can you share a real world example of a project or a team that neglected code health and it led to significant productivity issues?
Yeah, sure. I think actually these stories is what made me truly pragmatic and truly care about code health, to be like strategic about code complexity, not on one of the extremes on the term productivity spectrum. And that story is from my startup, from the company I was running. I think that was really, really motivating, not only because I, as a CEO, cared about product so much and productivity, but also that because it was a self-funded startup. So I was actually paying engineers to do the work. So if you see having productivity issues, you have really good incentives to fix it. And we had problems on both sides of the spectrum. We definitely had problems on the to clean code approach, like more kind of a long-term and investing in a long-term productivity. When both on the back end, I was spending too much time on stuff that didn't matter that much, especially in the startup world where you need to iterate so fast. But on the front-end side, I also saw front-end engineers building some sort of frameworks and reinventing wheels and being kind of strategic about what they're doing. But that's not what I wanted. And we needed to iterate. We needed to get feedback from customers very quickly. So yeah, that's on that side of the spectrum. But interestingly, we had problems on the other side of the spectrum as well. So sometimes they would just iterate and deliver stuff. But after a year, I think, or so, front-end engineers came to me and said, like, one of the key pages I wanted changes on, they just couldn't do that. They just couldn't deliver that. They were just telling me, like, it's too complicated. I'm doing something and breaking something, and I don't really understand what I'm doing anymore. And we had to start from the beginning. So we had problems on each side of the spectrum, which was pretty interesting.
Yeah, that's fascinating. So you're basically saying there was sometimes too much long-term thinking and too much short-term thinking at the same time.
Yeah, I guess in different parts, in different projects,
in different parts.
Yeah.
And so there's a balance you have to strike. You need some long-term strategic thinking. You need some short-term iterating, but you have to apply it appropriately in the appropriate contexts.
Yeah.
That's a tricky balance.
It is a tricky balance.
How do you strike that balance?
I believe the easiest way, and how it worked for me, is the ownership mentality, honestly.
Well, that's the other thing I was going to highlight that you said. It was your money.
Yeah, exactly.
So tell us more about that. That's interesting.
What exactly do you want to hear?
Well, I had a mentor of mine tell me that if you want to increase your engineering outcomes, you should treat the company's money like it's your own money. And it sounds like you're basically saying the same thing.
Yeah.
So how did it change things for you when it was your money?
Yeah, as I mentioned, you care about productivity not only because of the product, you start caring about productivity also because you're actually spending money on this. I don't think you can apply this to many software engineers because they're not paying their money for what they're doing. But I think what is realistic to expect is still to have this ownership mentality, like be kind of a product owners. I think that's the only way to truly strike the balance there. Because if we're saying, okay, and I've read it somewhere too, like it's a product manager's job to care about the product and it's software engineer's job to care about code quality so that you can continue iterating in the future, right? But I don't think it's a perfectly valid statement because once you do that, it's kind of a distributed responsibility and you have this push and pull and depends on who pushes harder and it's pretty tricky. Because product managers wouldn't have half of the story, right? They're not exposed to the code base. They cannot reason about the tech debt and all that stuff. So I think the only good solution here is for engineers to be more product focused, to be more like product owners. And engineers have much higher chances of having a full picture.
Do you have an example of an engineer who did a good job of learning how to think more like a product manager and how that helped them be more successful?
I had a colleague at Google who had an A4 paper printed in front of her, and above her desk there was a paper saying, user problem is bigger than engineering problem. And honestly, I think every engineer should have such poster, at least in their head. And always remember that ultimately what we're doing, the ultimate cause for this is to build products and to help our users. If you can remind yourself about this regularly, I think inevitably you will be more productive, you'll be more product focused, and will be motivated to find the right balance on that term productivity spectrum.
Great. So I think we have a general sense of the answer to this next question, but maybe give us some more specifics on how you selected the topics that you cover in the book, and then we'll dive more into some of those topics.
Yeah, it happened very organically. As I mentioned before, the book is a story of a healthy code base. So every chapter of the book is an important part of that story. So when I was about to start the book, I already knew pretty much the name of every chapter and more or less the content of every chapter. And there are two parts. If you look in the first part, it is structured around a code complexity model, about 3 complexity problems: change amplification, cognitive
we'll
load.
talk about them, but yes.
I'll just mention them here. So unknown unknowns, and there are 7 complexity causes. And then there are multiple chapters. All the other chapters from part 1 address 1 or 2 of those complexity causes. So chapter 3 is mostly design by contract, is mostly about true interfaces. Chapter 4 is about simple interfaces. Chapter 5 is about having too many dependencies and application. Chapter 6 also about too many dependencies. And chapter 7 is mostly about obscurity. So that's basically how the first part is structured. And then there is also the second part, which is about code-related processes, the key code-related processes. It is about design docs, about trade-off analysis, about code review, and build versus buy decisions. And the reason there is this second part is that code health starts outside of code. And if you want to tell the story of a healthy code base, you need to talk about these code-related processes as well. There's an interesting related story, actually, from Google. I didn't invent the term code health. It is actually the name of a working group internally at Google. And I've heard that when they were discussing how to name that group, they were thinking about naming it something like code quality or something like this. But the reason for choosing the name code health was that a lot of the responsibilities of that working group was actually about these key code-related processes, like code review. And for the very same reason, there is a second part in this book, because if we want to talk about code health, we need to talk about code-related processes as well. Code health starts outside of code.
So to summarize a couple of things you said, it sounds like a lot of what we're talking about here is how do we get productivity towards solving user problems? And how do we do it in a sustainable way? So if we're too short-sighted, we can get productivity quickly, but then we can slow down. And if we're too long-term thinking, we may never get the productivity we want in the first place. We have to balance those forces. Is that a good summary of what we've discussed so far?
Yeah, that's a good summary. I think that's one of the qualities of this book that is very pragmatic. In some ways, maybe even more pragmatic than Pragmatic Programmer, that we really want to strike a perfect balance. It took me a long time to be balanced myself and to be more pragmatic. And I just wanted to share my experience about that.
Okay. Well, then let's dive in. You mentioned, as we start moving through some of the topics in the book, the 3 problems of complexity. And you mentioned it before: high cognitive load, change amplification, and unknown unknowns. Can you describe what those mean, and then give the listeners some concrete examples of what happens when we don't address those 3 problems in real software projects?
Yeah, sure. So you probably have heard about these complexity problems if you're familiar with John Osterholz's work. So these are change amplification, cognitive load, and unknown unknowns. He calls them complexity symptoms, but I actually think they're actual practical problems we're dealing with. So the first one, I started with the least severe problem. It is change amplification. And it's basically when your small change, which you think will be a small change, is amplified, and it actually results in a huge PR, like hundreds of lines of code across dozens of files, something like that.
Say that again. So it affects hundreds of lines of code across dozens of files?
Yeah, it's kind of you expected it to be simple and simple change in a single file or in a couple of files. But
and it just ripples throughout the entire code base.
Exactly. Yeah.
Okay. So that's change amplification.
It is change amplification, but it is the least severe of the complexity problems. There is a very nice diagram in the book in chapter 2, which connects complexity problems to productivity problems.
Right. Now, least severe doesn't mean it's not severe. It just means it's less severe than the other two.
Yeah, exactly.
Okay.
And it depends on the scale, right? If you have like 2 duplicates and there is no obscurity around that they duplicate each other, you're probably fine. You can change it in 2 places, 3 places. It just affects the development speed. But development speed is just one of the productivity problems. There are more productivity problems which are probably more important, like buggy products.
Well, before we talk about those real quick, I will put a link in the show notes to a previous episode with Vlad Kononov where we talked about balancing coupling in software design. And he talks a lot about how you would handle this kind of change amplification. So we'll include that in the show notes. So change amplification is the least severe. It doesn't mean it's not severe. What's the next most severe of those 3 problems of complexity?
Yeah, so just let me finish answering to the previous one.
Yes, that's right. Sure.
Because it is the least severe because it only affects development speed. But there is also another productivity problem, which is buggy product. We don't have any bugs in the product. Another productivity problem is developer exhaustion. So the problem with these problems is that if you look at the graph, they are all very much interconnected with each other: developer exhaustion, bugs, and code complexity. And there are a bunch of vicious cycles there. So it kind of reinforces itself.
Yeah.
And if we're talking about change amplification, it's kind of isolated in this productivity diagram. It doesn't participate in these productivity regression vicious cycles. That's my understanding why it's the least severe problem. And there are nice visualizations in the book about it. Okay. And I think I agree with John Osterhood here. So we're on the same page. I'm pretty sure he says the same thing, like change amplification is the least severe there.
Again, it's not that it isn't severe. It's just not the most severe.
Yeah. It depends on the scale.
Right. That exactly. Okay.
Then the next one is cognitive load. And that's something you typically think of when you hear code complexity. So that's what you're thinking, okay, that takes too much effort to understand this code, to actually digest what is happening here. That's basically cognitive load.
Well, that could probably be subject to competing forces as well, couldn't it? Like maybe, what could that look like? 10,000 lines in a single function? Would you call that cognitive load, perhaps?
Yeah, definitely. Definitely, yeah, because you need to understand all the dependencies between lines there, I guess.
But then what about if I split that up into like 20 different services and then I inject them all into one thing? That could be the opposite end of the spectrum where I've maybe over-decomposed, and that would also increase cognitive load.
Yeah, there are definitely different ways in which you can achieve this. You can make things complicated in many different ways.
Many different ways. Well, as Neil Ford has said, developers are drawn to complexity like moths to a flame, often with the same outcome. So this is how it goes.
Yeah, but it is really bad having high cognitive load. You may need to spend many hours to actually understand what's going on. Sometimes you may not be able to understand it yourself, but probably you will find somebody who can understand, hopefully. So yeah, that's kind of attributes of this cognitive load problem. It's bad, but it's not the worst.
Mm-hmm. So the worst is coming. Yeah.
Yeah, the worst is still coming. The worst is unknown unknowns. And that's basically when you do not have some information that you really need to accomplish a task at hand. So if you want to do something, but you do not know where to start, or even worse, you don't know what you need to know to do this correctly. So there is some obscurity involved here.
So can you give me an example of, you just said, for example, there's something I need to know, but I don't know that I need to know. Has this happened to you or to team members maybe that you've worked with in your startup, where you discovered later that the actual issue that you were struggling with was unknown unknowns?
Yeah, there was an interesting story that happened to us in Google Maps, my first team at Google. At some point, we had a very senior engineer join our team, and he actually joined us as an engineering manager. But I guess at some point he was bored because it was mostly a maintenance project that we were working on. And I guess because of that, he was looking through the code and he deleted some configuration for our bad jobs. And the comment on that PR was literally something like, you don't need all this stuff. Like, this should all be done automatically. It was about choosing the right data centers for masters and for slaves for our batch jobs, which are basically improved MapReduce. You can think about it like this. And what happened is one morning, literally all of our batch jobs, like 20 of them, started sending us an alert saying that we cannot start. The job cannot be started. These are daily jobs. And we cannot start because the jobs for yesterday are still running. And yeah, getting these alerts, I fairly quickly realized what's going on. The choices for masters and slaves for those jobs were all very, very poor. And all those jobs were in like previous stages, just choosing one node in North America, another node in Europe, and like trying to send all the data between them. And that's because automation didn't work. He was correct that ideally, if those jobs were written from scratch, it all should have happened automatically. But these were very old jobs that were written like 5 years ago or something like that. And at that point, there was no automation and it required manual choices. And it was really fancy logic. It was really complicated. It took me quite a lot of time to really dig down into like how it worked. And I actually wrote a pretty long page internal that was explaining how these configuration parameters are working, which became pretty popular actually. But he just went ahead and deleted that part of configuration. And so there are two learnings there. One is that you shouldn't delete something that you don't understand why is it there in the first place. And that's what is called Chesterton fence, and we can talk about this. But there's also another problem there, that there were no comments in those configuration files explaining why do you need all of this configuration and how does it work. So I can definitely relate to him being confused about it and trying to do something about it.
Okay.
Can your software engineering team plan, track, and ship faster? Monday Dev says yes. With Monday Dev, you get fully customizable workflows, AI-powered context, and integrations that work within your IDE. No more admin bottlenecks, no add-ons, no BS. Just a frictionless platform built for developers. Try for free at monday.com/dev. You'll love it.
So next in the book, you explore the 7 causes of complexity. So describe for listeners what these 7 causes are, and then how these tend to show up in a code base. Because the goal here, as you've said, is to create people who are guardians of code health. And to do that, we need to understand complexity. So what are these sources, and what would we see in a code base where we're not properly considering these 7 causes of complexity?
Yeah, sure. So let's go over them in the order of decreasing severity, roughly. So the first one is obscurity. And we already started talking about this. The previous
unknown
example,
unknowns, yeah.
Yeah, unknown stuff. The previous example is missing documentation, missing comments. That's a very common example of obscurity. But obscurity is so general. It manifests in so many different ways. It can be obscure naming. That's another very popular manifestation of obscurity. But also, there are things that are really hard to avoid. And even it can be a necessary trade-off, obscurity. For example, if you're thinking about event-driven design, it necessarily has some obscurity in it. If you're trying to debug stuff and you're trying to reconstruct the chain of events that caused this thing, like that's not an easy thing to do, right? There is some inherent obscurity there. And sometimes you intentionally agree to have an obscurity, but as much as possible, I guess it's better to avoid it. The next one would probably be complex interfaces. Complex interfaces probably don't need any description, right? It's kind of intuitive. But the problem with them is that it actually cause all three complexity problems. So if we're thinking about change amplification or cognitive load on known unknowns, all of that can be caused by having complex interfaces.
This be an interface with lots of operations, or maybe the operations they're not cohesive, they don't belong together, these kinds of things.
Yeah, and even like having too many parameters in an interface is not
too many parameters. Yeah. Okay.
Like confusing name, and quite a lot of different things can go wrong with interfaces. But there are interfaces that appear simple. They can be simple to read and understand, but they still can be complicated. They can be hard to use. For example, if you think about assembler is most of the commands, they're pretty simple, right? It's easy to understand what they're doing. But if you want to do something in assembler, even device drivers, they're not being done in assembler these days, right? Because that's too complicated. You need to learn all those patterns, how to use these simple interfaces to do anything useful. So simple interfaces are about not being simple to read and understand, but also about simple to use as well. Yeah, we had an interesting story internally at Google. We were very passionate about implementing a complete CRUD API at some point. And we were talking about this like delete, update, create, all of those methods, and spent quite a lot of time doing this. And then later realized that actually the two teams that were using them, they didn't need this granular APIs. They actually wanted like more specific APIs that would address their use cases. But we were just going forward with this clean approach to provide a full API, which doesn't make sense in hindsight. So I'm really, really cautious about building something that would solve any problem. Just use it however you want to use it. This kind of arguments are not the best. You can end up with having very flexible API that doesn't really help. Yeah, sometimes you need that, right? If you're writing a public API and truly do not understand what it will be used for, and you want to give developers some freedom to experiment and build whatever comes to their mind. But often that's not the case. Often when we're building an API, we already know what are the internal use cases for that. And we just need to spend some time to make it not just appear simple and be easy to understand, but also be easy to use as well.
Yeah, that's a good call out to a previous episode I did with Yuval Lowy on his book, Writing Software. And everything about his methodology is about driving things via the use cases. So we'll put a link to that in the show notes as well, because you called out use cases a couple times. So that made me think about that as well. So we've talked about obscurity. We talked about complex interfaces.
Yeah.
We don't necessarily need to go through all 7 causes of complexity because listeners can get the book and then we can continue on. But were there any other causes of complexity that you wanted to highlight where maybe they affected a team that you were working with, or maybe a team successfully addressed one of these causes and it was noteworthy?
Yeah, I think one of the causes that I see being addressed really well at Canva, that's where I'm working right now, is unfamiliarity. So just historically, Canva was very good about keeping things consistent, especially when Canva was smaller. Right now, it's a bit more challenging. And that kind of makes sense too, because if you think about consistency, the first thing you need to understand is whether it's consistency about code style or consistency about code quality. If we're talking about code styles, it's simple, right? You just have a code style, you have a proper formatter used by everyone, and it just works. It's great value for money. But if we're talking about code quality, it's a bit more complicated. The next question is whether we're talking about consistency across like the whole organization, the whole code base, or are we talking about consistency specifically within a team? So if your organization is smaller, it's more like a team consistency than organization. And it's much easier to communicate those global rules and make sure they are consistently applied across the code base. But in general, the value, especially as the company grows, the value kind of decreases because you don't work in other teams' code bases as often. And also, it's so hard to communicate those rules and be consistent about them. So across the company, it becomes a bit challenging, and the value for money is probably not that good. But if we're talking about consistency within a team, I think that's very, very important because the value is much higher. You're actually working on the same code base, and the cost is much lower because you have just a few folks you need to agree with and make sure that you communicated those rules. And you just be consistent about how you do things in your code base. One global rule that we have at Canva, and which I personally now benefit a lot because I work on the authorization project, is that access checkers are very well structured. There is a well-defined structure of access checks across the whole company. So it means that we can actually improve this over time because it is consistent for different teams. If it wasn't, if every team was doing access checks in their own way, it just wouldn't be possible.
I think a lot of people are doing access checks in their own way, so that might be something that they could learn from. Let's move on to discuss some design principles for code health. So, there's a lot of books written about principles and practices, and you mentioned specifically some design principles. So let's talk about what those are and then how those can affect code health.
You're opening a Pandora box, honestly, because I guess I could answer with half of the book's content.
Yes, each one of these could be an episode unto its own, but just give listeners a taste. Like design by contract, for example. What does that mean, and how does that help with code health?
Yeah, sure. Design by contract is very crucial because you need to trust interfaces if you want to keep your code reasonably simple. If you do not trust interfaces, if there is not enough information in the interface itself, or if you cannot trust it, like you end up adding quite a lot of complexity into the code to just get around it and just have those safety nets. So it's really costly thing not to have interfaces that you can trust. And I think the only way to solve this trust problem is to follow the design by contract paradigm. It's a pretty old one, right? And I probably don't need to explain what it is.
You might actually, because, every year there's new people in the software industry. So, some of our listeners who are new to the industry may not be familiar with it. So if you don't mind, give us just a brief, you mentioned interfaces and contracts. How do those relate? What is design by contract?
I think it all starts with modular design, and I will use the term module as John Osterhutz used it, basically anything that has an interface and implementation. I think it goes all the way back to Parnas's definition.
It does. A module is something with an interface, inputs, outputs, and inside it should be a black box. So it could be a function, and it could be a system, and anything in between.
Yeah. But then if you want modules to be useful, if you want your decomposition do not look like foo, which calls foo1, foo2, foo3, foo4, like you really need to decompose it meaningfully and then have clear contracts for the other modules that you're calling from the implementation. So that's where design by contract really comes into play. It's kind of obvious things, but it's about being explicit about what the module does, documenting whatever is missing from the code, just writing down as documentation, and then internally enforcing those contracts internally in the module. So if you provide a class that has an interface, it is your responsibility to actually test that implementation, that it actually does what the interface promises to do. So that's basically the crux of the design by contract. You document what this model is doing and you internally enforce it. It's not only about tests. Assertions also is a huge part of it. They're especially useful for enforcing preconditions. Design by contract as a term was coined by Bertrand Meyer when he was working on his AFL language. And he used the terms precondition, postcondition, and class invariance, I believe. So basically, the way he was putting it is that if all the preconditions are met, then the module guarantees that all the post conditions will be met after the call and that all the invariants would still hold. So basically, that's, I think, roughly the definition he was giving. And yeah, when we're talking about assertions, they in particular help with validating the preconditions in runtime. I think Pragmatic Programmer makes a very good point about assertions, saying that it is naive to rely on tests only because, yes, you need good test coverage, and that's definitely the main contract enforcement mechanism. But apart from tests, there are billions of different states your program will go through in production in runtime. So having assertions in runtime actually is complementary to having good test coverage.
That's interesting. You said there could be billions of states your system could be in. So effectively, it sounds like you're making the case that assertions are another strategy for handling complexity.
Yeah, exactly. It's a strategy for enforcing contracts that at least all the preconditions are really met in your production system.
Right. And reducing the number of possible states that your system can be in to ones that you
Exactly,
are aware of. Yeah.
Yeah. It's if you do not do that, you will end up with having extra logic handling those edge cases. But so often you just need to say, hey, this code wasn't intended to be used with such an input.
Mm-hmm.
So you just fail fast, and that's the best thing you can do. You simplify the code, you don't handle those edge cases, and you make sure that the system, if it is alive, it is in the correct state.
Yeah, it's interesting. I think young software engineers often try to swallow exceptions, for example, and pretend they didn't happen. But more mature engineers want an exception to bring the system down. And that's essentially what you just described there.
Yeah, there are definitely cases when you want a safety net, like in particular, if you're having an important operation that is followed by some sort of a cleanup or optional operation that can be handled later. Maybe you want to wrap it in a try-catch, but in general, yeah, I 100% agree that, yeah, you don't want to mask errors.
Let's talk about dry. We talk about one of the principles for code health. You have some interesting takes on, by dry, I mean the don't repeat yourself principle. And I think some people maybe take this to the extreme, but you, I think, have a more nuanced perspective on this. So talk about the dry principle, how it relates to code health, and how to balance just how dry you should actually seek to be in your code base.
Yeah, that's one of the takeaways I hope from this book is that complexity is not a single problem. There are actually 3 different problems: change amplification, cognitive load, and unknown unknowns. And they all have different severity. So if we're talking about dry principle violations, the worst problem there is not change amplifications, even though it's the most obvious one. The worst one is unknown unknowns. So when it becomes really, really bad is when you do not really know that there is a duplicate somewhere else. It may look differently. It may be different code, but it's kind of still a knowledge duplicate, right? And if you do not know that there is a duplicate, then you're in a bad state, because these duplicates can, over time, they can start diverging, and that's the way towards driving your system crazy, having diverged duplicates, which are not really duplicates anymore. So if you can get rid of the unknown unknowns problems, I think we're already good enough. So we had this tooling practice at Google and tooling for marking the duplicates in code. Often it would be different languages like front-end and back-end, basically saying, if you change this, then change this. And if you have such comments in code, then basically you've addressed the unknown unknowns problem. There is no obscurity anymore around the fact that there is duplicate. And if there are not too many of them, it's probably not a big deal too. So you just need to change it in a couple of places. That's probably okay. But if you can avoid duplicates, definitely avoid them, because duplicates is often an overhead.
Yeah, and I'll reference again the previous episode with Vlad Kononov on balancing coupling in software design, because he references a lot of this in that book, and listeners who want to deep dive into that could check that out as well. So we've talked a lot about the elements of complexity and how to understand it. We've talked about some design principles as it relates to code health. But there's also processes that you discuss in the book about helping to maintain code health. Can you describe what some of those elements are of process, or what those processes are that help teams to either improve their code health or maintain their code health?
Yeah, definitely. So I think one process that I don't see being used a lot outside of Google, and Canva also uses design docs a lot, but I've seen a lot of companies which do not. I've seen a lot of companies which kind of ignore this upfront design, and it even has a negative connotation, right? When you say upfront design, like it feels uncomfortable. Like, are we not agile anymore?
Well, there's big upfront design, and then there's a little bit of upfront design, or just enough, right? And something tells me you're advocating for just enough.
Yeah, and that's the case. So I would argue, and that's what Google practices actually suggest, that a bit of upfront design actually helps you be more productive. And it actually makes the process a bit more delightful too, because you don't need to delete as much code as you would otherwise. So yeah, having a bit of an upfront design is definitely helpful. And I would argue that it's the best way to do trade-off analysis. And the best alternative to a design doc in most cases is a one-pager, which is basically a small design doc.
It's a small design doc. Well, yeah, I mean, you talk about trade-offs. Once you have an implementation, nobody wants to talk trade-offs anymore, especially once it's merged.
Yeah, exactly. But sometimes like the product would push you in that direction. You would need to talk about trade-offs. They would become obvious.
Yeah, interesting. Okay, so what differentiates a design doc from, I'm going to use the W word, when people think of, waterfall, they think of a massive specification with every possible thing. But since that's not what you're describing, you talk about a one-pager, but you said that's a very small design doc. But what is a design doc? What goes in it?
Well, there are always pros and cons, right? If we're talking about longer design docs or shorter design docs, it depends on, like, it won't catch as many issues if it's a shorter design doc, right? Okay. But at the same time, the return on investment may be the best if we're talking about short design doc.
Right. But if I'm a listener and I'm saying, okay, I agree with you that I should do some kind of design docs, maybe not big design up front, but some design up front, then what should I put in these design docs?
Yeah, so there are pretty standard templates there. You're just describing some background about the project you're about to do, goals, maybe non-goals. You provide a quick overview of the solution and maybe talk about some details. Depends on whether it's a big design doc or not that big design docs. But I would argue that every design doc should have at least some trade-off analysis in it. I think that's the very heart of design docs, that you're making decisions, right? Where will you make that decision? Will you make it in a design doc, or will you make it in some meetings? Or will you talk to stakeholders one-on-one and then get out of sync with each other over time? Or you just to design like in your head or on the whiteboard before coding? All these alternatives have so many downsides that it becomes pretty obvious once you write this down. And there is a trade-off table in the design docs chapter in the book, which clearly shows that design docs are absolutely the winner there.
Great. And I'll put a link in the show notes to the episode that I hosted Chad Michelle talking about lean software systems engineering for developers. And one of the key concepts in that book is the idea of gaining and maintaining a shared understanding throughout the project. And that seems like that dovetails really well with what you're describing with design documentations. They help us gain and maintain that shared understanding. Another aspect you mentioned of process is code reviews. A lot of people do code reviews, but maybe you have some nuanced perspective on what exactly good code review entails. Why should we do code reviews to ensure code health?
There are 4 goals for doing code reviews. And interestingly, when I first was doing good code reviewer classes internally at Google, we had just 2. That's one thing that was really surprising when I was writing this book. Then I actually discovered 2 more top-level goals. I can tell you the story about this, but let's go over the first ones too. The most obvious goal is high code quality, right? You basically just need the second pair of eyes. 2 heads are better than 1. You've done something, you definitely need to review it yourself, but you also need somebody else with a fresh eye to take a look and catch something. If they have a different expertise, if they're more senior than you, that's helpful, but that's not necessary because fresh eye actually helps a lot here. So many problems, even junior developer can catch just because they didn't see this code before. They do not have all the context you have in your head as an author. The second reason for doing code reviews is knowledge sharing. And that's huge because in our industry, we so often don't have the same context. If you go to meetings and start talking about solutions high level, you experience all the time, right? People try to understand what you're talking about and just give you a bunch of garbage advice just because they do not have any details and they're trying to help you, but they really cannot. But code reviews are very different because when you're doing code reviews, you have all this context in front of your eyes. So you have all the code is there. And if something is missing, you have an author there who is happy to help you, provide you with all the context that you need. So having the same context, being on the same page is very helpful for knowledge sharing because now having the same context, you can actually share what you think, share what you know, share your previous experiences and all this stuff. And that actually helps you grow so much faster. But there are two other goals there, which we didn't have originally in the good code reviewer classes internally at Google. And how I got to those goals is really funny because the original presentation, a good code reviewer at Google, it had three parts, but it had part for the goals and it had a huge part for the practical tips and tricks, which is basically like 10 practical tips and tricks that Google has learned over 2 decades doing like millions of reviews. And when I was writing the book, I was trying to do an experiment, just try to connect those practical tips and tricks to the goals. So you have 2 goals, you have around 10 practical tips and tricks, and you try to see what goals do they help with. And what I've found out is that nearly half of the practical tips and tricks didn't address any of those 2 goals. And that was something really surprising. And if you see this, then you can do 2 things, right? You can start questioning the tips and tricks, which probably wouldn't be wise because that's a lot of wisdom there, like that Google has accumulated over the decades. Another option is to question the goals. And that's what I did. And that's how I discovered 2 additional goals. And the third one is psychological safety. And psychological safety is actually, let's do the fourth one first because it's simpler. The fourth one is delivery speed. It's kind of obvious. You want to optimize your code reviews for delivery speed. You don't want to end up with this analysis paralysis thing, or you don't want to do like perfect PR out of this. There's no such thing as a perfect PR. So yeah, delivery speed is definitely another top level objective or top level goal there. But there's also one more that is not that obvious, which is psychological safety. And it all goes back to another project that was done internally at Google. You can find a lot of information about it online, which is named Project Aristotle. It was basically research on Google Teams. I think over 100 teams participated or something like this, trying to figure out what makes teams at Google productive. And there were a bunch of expectations what would come out from this research. Things like, what about complementary skill sets? Or maybe very good communication, like whether you have extroverts in your team versus introverts. But interestingly, if you look at the results of the research, nothing like that came up. It doesn't affect team productivity much. But what does affect team productivity much is psychological safety, first of all. Then the second predictor in the list is reliability, but it's a distant second. So psychological safety by far exceeds any other thing if we're talking about team productivity. So you really need to have good psychological safety climate in your team if you want your team to be productive. And how it relates to code reviews. Code reviews is... Oh, wait a moment. Let me explain psychological safety a little bit. Psychological safety is basically when you feel safe to take risks in front of your team. If you feel safe to look stupid in front of your team, like ask stupid questions or just bounce off weird, stupid ideas, well, lookingly stupid ideas, right? So that's kind of a psychological safety definition. And code reviews affect the psychological safety climate a lot, because code reviews is where you're faced with your errors more often than anywhere else, I guess. Maybe design docs is another thing, but design docs are they're more high level. You can argue, you can talk about things like, as Linus was saying, talk is cheap, right? Show me code. So in code, that's where you will see the actual errors, and that's where you will either deal with them professionally and will be open to discuss it, acknowledge them, and just build up the climate of psychological safety, or you're going to be defensive, not willing to talk about stuff, and just destroy psychological safety climate in your team. So that's another third or fourth goal of code reviews.
Well, as we wrap things up, were there any surprising revelations or lessons during the writing process?
So I just talked about code review, and that was really surprising for me to find out that there are two more high-level goals, because I was doing code review presentation, code review tech talks, probably more than any other tech talks in my life. And the fact that I only found out that there are two more high-level goals only when writing the book, that was pretty surprising, very unexpected. And yeah, by the way, I'm referring to internal Google presentations a lot here, but they're based mostly on internal documentation that was open sourced recently by Mexican and Alexander. So I'm not a whistleblower here, so I'm sharing something that is already present online. I'm just structuring it in a slightly different way. So yeah, I was really surprised that I found two more high-level goals there. But a couple more things also surprised me a lot. The first thing is that I was holding so tight to John Hood's definitions of complexity causes and complexity problems for such a long time. When I was working on it's kind of organic because my university course was based on John's work in a large extent. But as I was iterating on the content, these seven complexity causes were already circulating in the content of the university courses, but I wasn't calling it complexity causes because it was so much in my head that there are two complexity causes, dependencies and obscurity, and I must stick to it. But that's not the case, right? Because they're quite abstract. If you think about dependencies, and that's so abstract, and calling it, how is it helpful saying that dependencies is a complexity cause? Even though I mostly agree that you can track it down to dependencies and obscurity, but pragmatically speaking, if you want it to be practical, you want to be more specific here. And I think 7 complexity causes are actually much better if we're talking about obscurity, untrue complex interfaces, unfamiliarity, too many dependencies, duplication, and unstable dependencies. It's much, much more practical and pragmatically better than having just obscurity and dependencies. So that's one thing that struck me, that I held tightly to those two complexity causes for such a long time. And another thing is, I guess, about deep interfaces. If you remember John's work, he actually introduced the term deep modules. And if you look through the Google group discussions about this, you'll find Jimmy, I forgot his surname, some Jimmy was critiquing John for not being specific by what he actually means by deep modules. And they had a very long discussion there, and they didn't resolve it. And after some time, I just jumped in and we were talking with John about it last year. And I think what we've found out is that John by himself is not sure what he means by deep modules, because he's not sure whether we're talking about implementation there or not talking about implementation. And I had this gut feeling when I was starting the book that this need to be clarified, but I didn't know what exactly would come from it. And actually redefining it and saying, okay, let's talk about deep interfaces and leave everything else to saying okay, we don't want modules to be dysfunctional. That's a separate topic. Let's just decouple it a little bit and just focus on interfaces when we're talking about depth. That was a pretty big revelation.
So when you say deep interface versus a shallow interface, what exactly are you describing?
Yeah, so that's Basically, again, value for money. How much functionality does the interface promise in return for the complexity of the interface? So you can think of it as like functionality divided by complexity of the interface.
So a narrow interface that does a lot for you versus a broad interface that does very little for you.
Exactly. Yeah.
Okay, great. Well, this has been a great exploration of your book, Artie. If listeners want to learn more about you and the book, is there a website they can go to?
Yeah, definitely. You can go to codehilltheguardian.com.
Well, Artie, thank you so much for joining me on the show.
Thank you very much. Thanks for having me.
This is Jeff Doolittle for Software Engineering Radio. Thanks for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.